Today we are going to discuss about logic. What is logic? Can we apply logic in our daily lives? Does logic has a method to answer a logical question? How to answer a logical question? Is logic hard? These are the topics under logic. First, logic. Nature of proposition, two types of proposition, operation and proposition, truth values of proposition, forms of conditional proposition, three important classes of compound statement, rate of inference, and lastly, logical fallacies. Logic is a science of formal principles of reasoning of correct influence. Study of principles and methods used to distinguish valid arguments from those that are not valid. There are nature of proposition. First is the declarative sentence that can be either true or false. Second, declares, inform, or state, which uses period. The third one is symbolic logic that can be Q, R, S, and T. And lastly, subject and predicate.
Example of proposition. Number 1. Color blue is part of the rainbow colors. Number 2. The sum of 8 and 5 is equals to 12. Number 3. 6 times 6 times 6 times 6 is equals to 1296. Number 1. It is a proposition because it has subject and predicate and ends with a period. Number 2. It is proposition because even the answer is wrong, it's still a declarative sentence and answers true or false. Number 3. It is a proposition because it is a mathematical sentence. Number 4. She is beautiful. Number 5. Are you done with your project? Number 6. Tomorrow will be a sunny day. Number 4 is not proposition because she is a pronoun and we don't know who she is. Number 5 is not also a preposition because it's questioning. Number 6, it's also not proposition because there is no basis that tomorrow will be a sunny day. Are you shocked that there's a process in logic? Well, there's more.
There are two types of proposition. The first one is simple proposition. The simple proposition can be written in symbols with the use of variable single. Example: P is equals to I love watching movies. Q is equals to I enjoy eating popcorn.
The second one is the compound proposition. It is the result of combining simple propositions or producing new propositions from existing propositions. But before we construct a compound proposition, we should always remember to use logical operations and connectors which are and, or, not, negation of, if then, if and, only if, exclusive or. Example: I love watching movies and I enjoy eating popcorn. I love watching movies, then I enjoy eating popcorn. I enjoy eating popcorn if and only if I love watching movies.
Wow! I'm amazed! We want more! Logic also has its proposition. It's called operation of proposition.
Shocking, right?
First one is conjunction. Conjunction has its equation, P and Q. This symbol is equivalent to the conjunction and, but, also, in addition, and moreover. Example: apple is red and banana is yellow.
The hypothesis is the apple is red. The statement is true. The conclusion is banana is yellow, which is also true. The P and Q is equals to true.
Second, disjunction. Its equation is P or Q. Example: apple is red or banana is yellow. Your hypothesis P, apple is red, is true. Your conclusion Q, banana is yellow, is also true. Therefore, your equation P or Q is true.
Third one is negation. It uses not, false that, not the case that. For example, apple is not red. The negation of this statement is apple is red. Negation is the opposite of the given statement. The fourth one is conditional. It uses if, then, implies, only if, therefore, stronger than, sufficient condition for, if, follows whenever, is weaker than, is a necessary condition for. For example, if apple is red, then banana is yellow.
The hypothesis is the apple is red. The statement is true. The conclusion is banana is yellow. The statement is true. So P, therefore, Q is equals to true.
The fifth operation is biconditional. It uses if and only if equivalent, necessary, and sufficient. For example, apple is red if and only if banana is yellow.
The hypothesis is apple is red. The statement is true. The conclusion is banana is yellow. The statement is true. So P, if and only if Q is true.
The sixth operation is exclusive. P is exclusive to Q. It uses or. For example, apple is red or banana is orange. P, apple is red, so the answer is true. Q, banana is orange, so the answer is false. In this statement, the answer is true.
Now it's time for the fun part.
Truth values of proposition. In getting the truth values of proposition, you should be familiarized with the priorities such as negation, which is our first priority, then conjunction, next disjunction, next conditional, and lastly biconditional.
Example number 1. This symbol represents the negation, and we have the table down below to identify the opposite of the given letter, which is the P. So in this table, it shows that the opposite of the T is F.
Last column is the disjunction. So the given statement were combined as one by the fourth and fifth column. In this operation, if your P is F and your Q is F, then the answer is F. Then the rest of the statement is true. Example number 2. The example here is the same as the example number 1. It has the negation, which is the opposite of the given truth value. The next column beside negation P is conditional. There is a table below that if your P is true and your F is false, then the answer is false and the rest of the statements are true. The next column is biconditional. In this operation, if P and Q is similar like T and T, F and F, the answer is equal to true. Then if the statement is contrary, the answer would be definitely false.
The last column is disjunction. If your P is false and your Q is false, then your answer will be false, and the rest of the statements are true.
Next is example number 3. But wait, what is R? R is one of the symbolic logic to symbolize proposition. So, it's just the same as Q and R. Here is the chart. Let's go back to the example. First is the negation. It's just the same as the other example, even though there is an R. Next column is conditional, of not P and not Q. The last column is disjunction, of not R and not P or not Q.
Next step is called
Forms of conditional proposition. The first one is conditional, and the statement is read as if P then Q. Next is converse, and here is the statement. It is read as if Q then P. It's like the opposite of conditional. The third one is inverse. The statement where if not P, then not Q. And the last one is contrapositive, and the statement is read as if not Q, then not P.
So I'm gonna give you some example. The P statement is the apple is red. The Q statement is the sky is blue. Simple, isn't it? Next, as the inverse statement that is if not P, then not Q. It is if the apple is not red, then the sky is not blue. And lastly, as a contrapositive statement, which is if not Q, then not P, it is if the sky is not blue, then the apple is not red.